In this video, we're going to look at the main differences between row echelon form and something known as reduced row echelon form. So we're going to start with some definitions, and there's also some more definitions in your textbook on page 508 at the top of the page that will help you with this. Just make sure you have that in your notes for your quizzes and tests. It's kind of tricky at first. But when you see a couple examples, you'll be able to get the pattern. So basically, row echelon form is when you have a matrix that if there are rows at the bottom, so they're called zero rows. So if just all the whole row is zero, it has to be the bottom row of the matrix. That's that's rule number one. Okay, rule number two. A leading term has to be a 1. So if you look here, if there is a leading term, it has to be a 1. Okay, so here's some leading terms and they have to be 1s. It can't be 2s, 3s. Only leading term on the row has to be a 1. Okay? So, and then as you go down on the rows, the leading term has to be a 1 always to start the row. So 1, 1, 1. So this is going to be row echelon form here. Okay, like a little staircase pattern. Now, with reduced row echelon form, it's like one level above that. So basically, all the conditions of row echelon form must be met, but there's a new criteria. So, basically, here's the definition here, but I think if we look at this example here, we'll be able to understand a little bit more. So if we have a leading term of 1 on the diagonals here, on top of the 1 has to be a 0, and the bottom of the 1 has to be a 0. So you see in this first one here, on the first column, there's a 1, 0, 0. So there's a 0 under the 1. Okay. On the second column, there's a 1, a leading 1. And there is a 0 on top, 0 on the bottom, so that criteria is met. And on the third column, there's a 1 at the bottom, and there's a 0 on top. So basically, think reduced row echelon form is just like row echelon form, except that there's one additional criteria that your leading terms have to have 0s on top of the 1s. Okay? So I would go back and look at those definitions in the book. 508, you can really get an idea of what those are. And let's look at some examples to see which we can tell which is row echelon form or just reduced row echelon form, or it could be neither. So I want you to pause the video, look at your definitions, look at the book, see if you can get these on your own, and we'll go over the answer. Okay? So number 1 is just row echelon form. So I'm going to call it row echelon form. Okay, it's not reduced row echelon form because if you look at this column here, even though I have a 1 leading on the second row, there's a 2 on top of it, so it's not a 0. This is just row echelon form for number 1. Okay, for B is neither, because if you look at the definition, this has to be on the bottom. That has to be on the bottom row. If it's a 0 row, it has to be on the bottom. Okay, so that's not row echelon form or reduced row echelon form. Let's look at the next one. Okay, so I have a 4 by 5 matrix here. This is a 4 by 5 to help you with the numberings there. So this one is just going to be row echelon form. Row echelon form, and I hope you can see now that if I look at this leading term of 1, that's not a 0, it's a 2. So that's just row echelon form. The reason why it's row echelon form is because I have a stair-stepping pattern with my rows. My leading term is 1 on the first row, 1 on the second row, 1 on the third row. On the fourth row, there's a 1. So the only difference, it's not reduced row echelon form because of that 2 there. If that 2 was, and also there's a 3 here, and a 4 here. There's lots of reasons, but so let's look at the next one. For D, this is reduce row echelon form because I have a stair-step pattern. My bottom row is all zeros, and if I look at my leading terms on my diagonals, there's zeros on top and bottom of each one of those, okay? Let's look at E. So E is neither, because of that leading term has to be a 1. If we multiplied row 2 by 1/2, we can turn it into row echelon form, but in this case, it's neither, because that leading term has to be a 1. And F, our last one here, F is reduced row echelon form because I have my leading terms of 1 or non-zero or 0 row on the bottom, and on top of the 1 and bottom of the 1 has to be a 0, and that works true for all that. All right, the last example we're going to see here is this one. So again, I encourage you to pause the video and see if you can figure out what's going on here, if this is what type of matrix this is. Okay, and this one is reduced row echelon form because I have leading 1s, and the bottom row is all zeros, which you can have that. And on the 1s, there's a 0 on the bottom, and there's zeros on tops. So that's all we're gonna look at here for this video. In the next video, we're gonna look at some Gaussian elimination with back substitution, how to solve some matrices like that. So half of your homework is just identifying if it's row echelon form, reduced row echelon form, or neither.